Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. Alright, this is a pretty heavy question, and I think I'm going to need to charge my pencil after this, so maybe the last one, and then we'll stop it here, I guess, for now. Question 6, 4-mark question, so rather light. Consider the following function. H of x is equal to 2 over the square root of x minus 1 plus 1/2 for x is greater than 1. Find h inverse of 1. Find the domain of h inverse of x. Pretty heavy algebra. Often don't see this so much on applications interpretation. Interesting question all the same, but very kind of heavy algebra. Okay, let's work through it. Part A. Part A actually is not so bad. We're asked to find the inverse, h inverse of 1. So remember, we have a set of inputs and a set of outputs, and we have certain inputs like 0 or 0, 1, 2, 3, 4, something like that. And we have a function. In this case, it's h of x, and it will take those inputs and it will map them to certain outputs. In this case, we feed in a value of, let's say, 0 into this x value, and then we get something out in return. Maybe, in this case, if we feed in 0, we might not actually get an output. But if we feed in a value of, let's say, 4 or something like that, we will get a value. Or feed in a value of 2, for example, it looks like we'll get an answer of 2.5, for example. So we feed in value of 2 and out comes 2.5. This is our idea of a function. We have a set of inputs. The function is some kind of rule, which once we input or we plug in those inputs, it gives us an output. And an inverse kind of does the opposite. You feed it in these values and it will tell you what that original input was. So you can feed it those outputs and it'll tell you what the original input was in that case. So this h inverse of 1, what they're saying is, if the output of our function was 1, what was the input? So here we know that the output in this case is 1. That is to say, the y value is 1. What was our input? And in this case, all we need to do is just write 1 is equal to 2 over x minus 1 plus 1/2. And then we can go ahead and end solve. So let's go ahead and end solve this for x. I'm going to go ahead and do that here. So looking back to the calculator screen, here we go. Menu, algebra, numerical solve. 1 is equal to, pretty intimidating question, or at least looks kind of like it. X minus 1 plus, we can write 0.5 or just leave it as a fraction. 1 over 2, and then ask our calculator to solve for x. And the value is 17, so not too bad. When they're asking us for an inverse, we're asked if the output itself, the output is 1 in this case, what was the input? And in this case, x would be equal to 17. Not too bad of a question. This is an extremely challenging question, at least I think. Alright, consider the following function. We want to find the domain of h inverse x. So domain is usually the set of inputs. So if we have this function h of x, the domain is a set of inputs that we can feed into the function, and that they'll produce a set of outputs. And in this case, just looking at the function that we have now, the set of inputs, this is for h of x. The set of inputs would be limited because we can't have a 0 in the denominator, and the square root, we can't have like a -1, because we can't multiply some value by itself and get a negative, because something times itself, negative times a negative is a positive. So just looking at the domain of this h of x, there are some values that we can't actually put in. And that's what they're asking us here, but they're not asking us about h of x, they're asking us about h inverse, so the inverse of this. So usually the domain is a set of inputs that we can put into a function and they'll have an output. If we're asked for the domain of the inverse, we're saying what are these possible values that we can feed in, and that they'll produce some output. So how can we do this? H of x, we have inputs and they generate an output, but they'll only generate certain outputs. What are all of the outputs that are generated? If we know all of the outputs that are generated, then those outputs themselves must have an input. So let's find out the total collection of outputs. What are the total collection of outputs here? Because if we know if h of x itself has an output, then we should be able to feed those outputs into our inverse and get back to an input. Get back to what was originally an input. Okay, so let's go ahead and try to find that. Let's go and look at our function. I think that's going to be the easiest way. Alright, so here we go. Let's write out this function. So 2 over the square root of x minus 1 plus 0.5, or let's write it out as 1/2. Alright, let's write out this function. Here it is. Okay, the set of outputs. So we're looking for the set of outputs that we could feasibly put into our inverse. And it looks like we can't put any negatives. We can't put any negative values because those don't have an output. We can't say, okay, what was the input? But it looks like we do have certain values that go all the way up to infinity. So any value up to infinity could potentially be an output of this original function, or an input for our inverse. But it looks like, and let's zoom out a little here, zoom out, it looks like after a while we reach some kind of asymptote. And let's go graph trace, and just moving along here, we see as we move to the right and get larger and larger values, we approach some kind of asymptote. And we can even use graph trace, for example, and ask what the value is when we're at, I don't know, some massively large value. And it looks like we reach some asymptote when we have, let's say, in this case 50 million, we're at a value of 0.5. So the set of outputs for this original function are all the way from positive infinity to 0.5. All the way from positive infinity to 0.5. So let's go back to this home screen once again, or the document. And I realize this looks a little messy right now, but what do we have? We have all the way from 0.5. We have inputs all the way from 0.5 all the way to positive infinity. And if that's the case, we should be able to plug in values from 0.5 to positive infinity into our inverse function, and they should give us some kind of output for our inverse function. Remember, inverse is reverse the inputs and outputs for a regular function. So all the way from 0.5 to infinity, we have some values that once inputted into our inverse will generate an output. So find the domain, that is to say the set of possible inverses, the set of possible inputs for our inverse. Well, in this case, it looks like the domain of h inverse x is greater than 0.5 and less than positive infinity. It's not equal to 0.5 because we have this asymptote, and the asymptote is something that approaches a point but never reaches it. There it is. Yeah, that's what I would say. There's potentially a more maybe complex kind of algebraic explanation, but I think that's as best as I can do in terms of simplifying it without getting into some more kind of muddy waters. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.